If you've worked a lot with DVI, you'll notice there are a number of different interface types. DVI stands for Digital Visual Interface, and it's a very standard interface to use these days, especially on our higher resolution displays. There are two kinds of DVI. There is a single link and there is a dual link. This does not refer to the number of cables that you're using. It refers to the amount of signal that is passing through a single cable. If it is a single link connection, then it is sending 3.7 gigabits per second of traffic. That is referring to enough so that you could send HDTV signals at 60 frames per second. Sometimes you need more data to be sent through. Those are sent over dual link connections. That is 7.4 gigabits per second, effectively twice as much. That's able to do HDTV at 85 frames per second. If you're working with an analog signal over DVI, it's going to look like this connection at the top, which is a DVI-A. That A stands for analog. Conversely, there are digital signals on a DVI-D, that D being for the digital connection, and there are both single link and dual link connections for the DVI-D. And lastly, there is an integrated type called the DVI-I, where I could send digital and analog signals in the same connection, and you can see the two different types of single link and dual link connections here for DVI integrated. Another type of display connection that you'll see for video is the DisplayPort. This is a standard that is from the Video Electronic Standards Association. What's nice about this standard is it's royalty-free. So implementing this type of connection in your computer, in your laptop, the manufacturers don't have to pay a fee for doing that. There is data sent across this that is sent in packetized form. This is very much like sending data to a PCI Express or sending data across an Ethernet connection. It's simply taking that digital signal and sending packets over this particular connection. This is also a connection type that's compatible with HDMI. It's compatible with DVI. All you have to do is put a very simple passive connector on the end, and you can also connect to those types of interfaces. You may see different form factors for DisplayPort interfaces. These are two of the common ones. This is the standard DisplayPort, and here's the DisplayPort you often see on Apple devices called a mini DisplayPort. We often associate HDMI with television, but of course it could also be used for computers as well. One nice thing about HDMI is that you can send both video and audio over exactly the same cable. This is a completely digital connection. You do not send analog signals over an HDMI cable. With most large devices, we tend to see this large 19-pin, what we call a Type A connector for HDMI. HDMI is a standard that requires that a payment be made to use it. It's something that has to be licensed. So this is not a free connector that a manufacturer can use. It is a proprietary type of connection. You might also find mini HDMI, especially on smaller devices. What we call this is a Type C connector, and it's really designed for much smaller form factors. There's even a micro HDMI that's a Type D. There's even smaller versions of that you can fit onto the very, very small portable devices as well. A video display connection that's been around for seemingly forever is a VGA connector. You see it normally packaged in this DE15, this 15-pin connector. You may also see it written as DB15, although that would be a much wider connector, but both of those are generally acceptable to describe this type of video connection. It's also almost always colored blue. This is a standardized coloring scheme from the PC System Design Guide that the industry uses. So often on the back of your computer, you'll notice that the interface for VGA is colored with a blue color. A VGA connection outputs an analog video signal. You may notice this if you try to take a video display and extend that VGA out over a long distance. You may notice ghosting or information not quite looking right on the other side because there's signal loss along the way. And unlike a digital connection where you either get the signal or you don't get the signal, with an analog connection on the other end, you simply get a degraded display that does not look quite as crisp as it should. We see RCA connectors used for both audio and video. It's a connector type that's been around since the 1940s. Sometimes you'll see it referred to as a phono connector. An RCA connector is very commonly used for composite video. Composite video uses a single link. Usually it's a bright yellow. We can see it right on here as that single composite video. It's often used in conjunction with audio, so you may also be running a left and right, red and white audio signal along with the yellow video signal. RCA interfaces are also used to send component video to another connection. You can see the 3 component video connectors on the top of this device, and they're marked Y, PB, and PR. The Y stands for luminance. It's the amount of brightness of the signal. The PB stands for blue, and the PR stands for red. And these are usually used for higher definition, and you'll see that the colors are very much the same when we look at them. For the green is the Y, and then the PB for the blue, and the PR for the red. All you have to do is match those up on the back of your device, and you're generally sending high definition signals down those connections. A type of connection you commonly see in more industrial type environments is a BNC connection. That stands for Bayonet Neal Conselman. And it was Paul Neal and Carl Conselman who came up with this type of connector. It uses that bayonet, which means that you push it in and you turn it and it locks. It's very difficult to pull that out unless you then push it in and turn it to be able to get it out of that connection. And it's used primarily on higher end video where you have to make sure it's always connected. You want to be sure it doesn't accidentally slip out of that connection there. Generally, we see this being used with RGB HV, where the green, the red, the blue, the horizontal sync, and the vertical sync are all sent over different wires. You can also see this being used on component video as well, where you still have that Y, the PB, and the PR, and sending all 3 of those connections with that connector on the end that slides in on the bayonet and locks into place. A video type that uses a mini DIN6 connector is one called separate video. It's abbreviated S-video. It's an analog video type. It's not commonly used these days, but you'll certainly see it on legacy devices. And it has 2 channels, one for intensity and one for color. This is usually used for lower resolution and lower definition pictures, but it's one that provides this single cable just for the video. In large data centers, it's not uncommon to see video being sent over twisted pair using these RJ45 connectors. You see this a lot when you need to extend video from many different devices that might be in a rack all the way back to something like a keyboard video mouse extension. That way you can have a central console in your data center, and over a single RJ45 Cat5 type cable, you can send all of those signals, the keyboard, the mouse, and the video, to any of the devices in your environment. And when you're dealing with that many devices in a large data center, being able to use an existing infrastructure like RJ45 makes the job very, very easy. The cables and connectors on a SATA drive are very unique. You can see on the back of this SATA drive, you have the normal Molex power connection. There are some jumpers here for making configuration changes to the drive. And here's the SATA connectivity. And you can see here, there are 2 different interfaces. Both of these are associated with the SATA connection. The first one, the large one on the left side, is a 15-pin connection. That one is for power. So you may want to use this power connection on these older SATA drives like the one here. You would also have the choice to use the older Molex connection as well. But if your power supply has a power connection specifically designed for SATA, you can simply plug in right there. The smaller connector is the data connector. This is the connection that is 7 pins that are going directly from the drive and plugging into the motherboard using one of those very thin SATA cables. If you're looking at the cable side of things, this is what they look like. This is the SATA power connection. Notice that you have that 15-pin connector, but it's got this little L at the end. That means you can only plug it in one particular way to the SATA interface. The SATA data cables, practically the same thing except smaller. They're the 7-pin connectors. Again, they've got the little marking on the end, so you can only plug it into the drive or onto your motherboard in that one particular way. Sometimes you'll have a connector that combines both of these together. This makes it a little bit easier to plug in because it's a larger connection that can only go in one particular way. Makes it very easy if you're running both the power and the data to run it all along the same cable system and plug it in with a single connector. A PATA drive has, of course, different connectors on it. You may also see this referred to as an ATA drive. We also call these IDE drives. We call them eIDE drives, but they are effectively the exact same interface connector on the back of the drive. If we look at the drive, we can see the 4-pin power, the Molex connector on the back. Here are the jumpers that you might have for making configuration changes. And here is this 40-pin connector. As you can see, the data connector on PATA much larger than the data connector on that SATA drive. There's 40 pins in 2 rows going all the way across, and it's difficult to see here. Usually there is one pin that is missing, that is filled in on the ribbon cable, so that you can only plug the ribbon cable in one particular way. If you look at a PATA cable and compare it to a SATA cable, you can see some obvious differences. The PATA cable, this 40-pin connector, is very wide. It's a parallel connection. So you have a lot of data that's going across all of these pins all at the same time. So it requires that it's this big ribbon cable inside of your computer case. The SATA cable, of course, much smaller. It's a serial connection where you're simply sending one bit after another. And so the connector does not have to be as large, and the cable does not have to be as large. And when you're working inside of a desktop computer, if you have these ribbon cables, it can take up some of the airflow space. People who move from PATA to SATA will often see that their airflow improves and the cooling improves inside of their computer because they no longer have these large ribbon connections inside of their system. We've looked at hard drive connections, but let's change our view into looking at a floppy drive connection. One thing that's very unique to floppy drives is the connectors and the power that's used. In fact, both of those are very different than any other type of connector inside of your computer. The floppy drive has its own way of doing things. I have on top of this a view from the back of a floppy drive and of a PATA drive here at the bottom. You can see the large 4-pin Molex, and you can see the tiny 4-pin power that's used on a floppy drive connection. Even the ribbon cable that's used is different. You can see this very large 40-pin PATA connection, and on the floppy drive, you have this 34-pin. It's still a ribbon connection, but it's a different size ribbon connection. You can't use the same connections as a PATA drive on your floppy drive. They are a completely different size. If you look at the cables plugging into the floppy drive, you can see they are very different. This is the 4-pin power, that smaller connector. You may also hear this referred to as a Berg connector, B-E-R-G, because that's the manufacturer of that particular connector type. The cables, obviously, you can see a difference. This is the 40-pin PATA, and on a floppy drive, you see it's a much smaller cable. It's only 34 pins, but still a ribbon cable. You can even see the colored line at one end of the ribbon cable to designate pin 1 on that particular connection. So they are made the same, they look very similar, but obviously are different sizes and they are not interchangeable. Here's a section of a motherboard, and we can look at this and see what these connectors look like from the motherboard's perspective. If we start over on this side, these small blue connectors are the SATA connectors. You can see they don't take up much room on the motherboard at all, and this particular motherboard supports 6 different SATA connections that you can plug into 6 separate drives on your system. This larger 40-pin connection, it even is marked IDE. That is the PATA connection for a traditional PATA type hard drive. This motherboard obviously supports both types of interfaces for storage devices. And then there's a floppy drive connection here at the bottom. You can see it's a similar layout as the IDE or the PATA connection, but obviously much smaller because of the 34 pins you would use to go to a floppy drive. SCSI drives, of course, have their own connector types. This is just one of the many types of SCSI connections you might see on a drive itself. Same type of idea. You have a power connection, you have some jumpers for configuration, and there's the SCSI connection that we have here. This is a very high density 68-pin SCSI connection that you can see here, but the idea is that there are many different kinds of SCSI. SCSI has been around for a very long time. The standards have changed a lot through the years, so you may run into a lot of legacy devices that might use these 50-pin connectors, these very small connectors that have locking mechanisms on the side, or like the drive we just looked at, it might be this 68-pin connector. These are relatively unique. When you see one of these kinds of connections, you can tell immediately that's not a SATA, that's not a PATA, that's a SCSI type connection. And if you just go through the list of all of the different major SCSI connector types, you'll find one of those on your system if it supports a SCSI interface. The SCSI cable itself looks very similar to a PATA connection. It is a ribbon type connector that's inside of your computer, but unlike a PATA connection, you can have many of these interfaces that are connected along the length of the ribbon cable itself. Unlike PATA, which only supports 2 drives on a cable, a SCSI connection can support 8 and in some versions 16 different devices all plugged into that same SCSI connector. So you can plug in one place on the motherboard and have up to 15 other devices along the length of that cable connection. If you're connecting a keyboard, a mouse, a printer these days, or even a mobile device, you're probably using USB as the connectivity. On the motherboard itself, you probably have a Type A plug receptacle that you're plugging these Type A plugs into. Sometimes you'll have a Type B connection. Usually that's on the peripheral itself. That might be on the printer or on the scanner. For our smaller devices, we tend to see these smaller plugs. So we might plug into our motherboard or our laptop system with a Type A, but the other side might be this mini B plug or even a micro B plug. One thing you have to be careful are some of these proprietary types. Here's a good example of one that looks very similar to a USB connection, but this is actually a non-USB. It is a proprietary connection that has no particular standard associated with it. On the motherboard itself or on your laptop or your mobile device, when you're connecting in that Type A connection, you'll see them on the back of the motherboard. Relatively obvious, and usually there's more than one. These days we connect them to the back of our computer. There's sometimes USB connections on the keyboards that we use. And of course, you can purchase a USB hub that has multiple connectors on there so you can expand out the number of connections that you can use for USB. The FireWire standard is declining in popularity, but there's still a large number of devices out there using FireWire. And the cables that you'll see are like these 1394A type cables. Here's a 4-pin that does not use power to send across the FireWire connection. Here's the 6-pin 1394A connector. That's one that does allow you to send power across the FireWire so that you can power up peripherals without having to connect them to a power source. There are also these 9-pin, these are the newer 1394B connectors, and they can also provide power. If you're looking at a peripheral, here happens to be a sound device, an audio device, an interface for your computer. You can see the FireWire right down here at the bottom. This particular device supports both a 6-pin connection and a 4-pin connection. So no matter what cable you have, you can simply plug into one of those. If you're looking for FireWire, you'll almost always see this FireWire symbol. And indeed, on this device, you can see the small symbol at the bottom designating the FireWire ports that you can connect to your computer. For your legacy computers, you'll probably see the keyboard and mouse using these types of round mini DIN connectors. These were usually colored a particular way, where the green connection is for a mouse and the purple connection designates a keyboard. They look very similar to each other, so it's very useful to be able to identify the colors because you can plug in the keyboard to the mouse port and the mouse to the keyboard port, and of course, neither of those will work when you do that. The name PS2 comes from the older IBM PC version of machines that was designated PS2. Those were the ones that initially used this particular kind of interface. Goes all the way back to 1987. These days we're using USB to connect our mouse and our keyboard. It's certainly a much more standard connector. It's a smaller connector. And of course, because it's USB on the back of your computer, you can use it for more than just a mouse and a keyboard. Another legacy connector you should be aware of, especially if you have a lot of legacy printers, is this 25-pin parallel connection. This is commonly used for printers. You can see the color of this parallel connection is usually purple. It might also be colored black, but on the back of the computer, it's this very wide 25-pin DB25 connector. Very obvious when you see it. So you'll plug in your printer cable to this 25-pin connection, and on the other side is generally a Centronics connection. This is this very wide connector that has these locking mechanisms on the end, an odd looking 36-pin connector, and it's named after the organization that originally created the connector type, which was Centronics. Most of the time you don't see this being used any longer. Most of our printers today are plugging in via USB, but if you have some older systems, they are probably using the parallel connection to connect up and use that printer. Before the advent of the PS2 port, and before we had standardized ways to plug into USB ports, we used serial connections. You'll sometimes see some of these legacy connections on the back of computers. They're these smaller DE9 connectors. They're relatively small on the back of your computer. They're easy to miss, and we would use it to plug in our mouse or plug in our modem to be able to communicate. You can also see it being used even today to connect to routers and switches and firewalls, those infrastructure devices that need to be configured manually from a front panel. So the technician will simply plug into the serial connection right on the front of that device and then plug into the serial port on their laptop or their desktop to be able to manually configure that particular system. Most of the time these days, you're going to see a 9-pin connection for this serial port, but sometimes, especially on older equipment, it might be a 25-pin, a DB25 connection. Most of the time, you're going to see this as a 9-pin connection. Sometimes you'll see this referred to as a DB9. It's probably more accurate to call this a DE9 connection, so you may see it written either way. Notice this is not a VGA port. It looks like it has the same form factor as a VGA port, and it does. The difference is the number of pins inside of it. A serial connection is only going to have 9 pins, whereas a VGA connection is going to have 15 pins inside of it. Another thing to look at is that on the computer interface that's on the back of your computer or that's on your laptop, you're usually going to have male connections coming out of that, and the interface that you're going to plug into is going to probably be a male connection as well. If you're looking at a video interface for VGA, generally the video is completely different. On the back of your computer, usually that's a female connection. So if you're not quite certain, make sure you look at the number of pins and you determine if that's a male connector or a female connector. If you're using Ethernet and plugging into your computer, then you're using an RJ45 connector. That RJ stands for registered jack. And it's probably more accurate to describe this connection as one that has 8 positions. You can see all 8 of these positions on the cable itself, and each one of those positions has a conductor. There's a copper connection associated with each one of those. So we'll sometimes call this an 8P8C connection to refer to it as an 8-position 8 conductor. This is technically not RJ45. In the industry, we've called it that, but the RJ type standardization refers to how the connector is wired and not just the physical connection inside of it. So it turns out we're probably calling this the wrong thing all the time, but now that we've standardized on how to refer to this, it's normally how you're going to see these described when you order them from a manufacturer, when you describe the interface on your computer, or looking at your infrastructure equipment. You'll almost always call it an RJ45. If we're connecting up a traditional phone line into a modem, we're using an RJ11 connection. You can see it's a little bit thinner than an RJ45. This is also referred to as a 6P2C to refer to the 6 different positions inside of the connector and usually the 2 conductors that you will see. But even as this describes, I just pulled a cable out of a box and took a picture. It's using more than 2 conductors, and that's not unusual. Some of the standards that you'll see will use something like a 6P4C. Sometimes it'll be a 6P6C connection. But usually when we're talking about an RJ11 connection, we're only talking about needing 2 wires because that is what we're using when we're plugging into a traditional phone line. If you're connecting an analog audio input or output into the back of your computer, you're probably using one of these TRS connections. You may also see these referred to as a 3.5 millimeter connector or a 1/8 inch connector. The TRS stands for tip, ring, and sleeve, and that refers to the different signals that you are sending to the different parts of that particular interface. Although there are colors on the back of your motherboard, they don't always follow a standard. So if you are in a tight connection and you're trying to plug in the left channel and the right channel and get those exactly right, you may want to get a flashlight and get back and look exactly what is marked on the back of that computer to make sure that you're plugging into the right connection, because all of those connectors look exactly the same and they fit exactly the same interface. So it's important that you plug the right cable into the right connector.